All right, you know what I think we should do?
An intro.
An intro to the stand-up, Prime.
All right.
You got this.
Are we doing a podcast?
We're doing a podcast today every Wednesday and Friday, live on Twitch, 11 a.m. The stand-up happens, and today we have a special assortment of guests. We have Tej, as always. Say hi, Tej.
I like when you say that the stand-up happens every day, but then you say it's Wednesdays and Fridays. That one, you didn't say that this time, but you've said it the last few intros. Anyways, hi.
Actually, this is the second time I said what day it happened, so guess what?
No, I know. Last
You're
time you
wrong
said
with every few.
No.
Oh, we're being technical. Hi, I'm
Josh,
technical
bring
TJ.
Bring it back from the last episode.
Stand-up, which is streamed every day, Wednesday at 11 and Friday at 11 a.m.
You literally said it happens every day,
Every day.
Wednesdays and Fridays. Which
So what we've learned, okay,
Oh,
what
hold
we
on,
have
don't
learned
time it.
today, this is insane. What we've learned today is that when Prime does actually do the intro correctly, Tej will then immediately derail.
Torpedoes it. He torpedoes it.
What
now
the
we're
hell?
derailed.
This was our one chance. The plane was like leaving the runway, and you were like, I'm gonna be the chicken that flies into the engine.
Casey, here's my question. Is this called the stand-up, or is it called the well-run meeting?
Good point.
Anyways, sorry. All right. We also have with us Casey, as usual. Say hi, Casey.
Hi, Casey.
I knew one of you sons of bitches would do that. And a very special guest today, which is Ryan. Is it Fleury?
That's perfect, actually. I've
That
never
was,
pronounced
was leaning
better.
into it, yeah.
Yeah, I mean, I knew it was French. I didn't know how, what you gotta do with that,
Yeah.
Okay, well, anyways, say hello, Ryan Fleury.
Hello, Ryan Fleury.
Nice.
Oh, that was wonderful.
Thank you. And today we have a very special topic. It's one of those evergreen topics. We're going to be talking about debuggers. And since I'm a Printf debugger, TJ, I don't know what he is. Casey, definitely a debugger. Ryan Fleury is the one who writes the debugger. So we figured he'd be the best single person to bring on and help us understand all the buggers. Ryan, I have a very important question to kick this off. Is Printf debugging an abomination towards man, or is it a perfectly viable strategy?
Well, yeah, I think so. The first thing I would probably say to introduce someone to the topic, if they had just started programming and they figured out how to insert log statements into the program to sort of see what happened. The first thing I would say is that there's no dichotomy between that and what a debugger is offering. There's no dichotomy between logging and what a debug, the information that a debugger is actually getting. The only variable is what work you actually had to do in order to get a log of information out of your program. And so the first thing I would describe about a debugger is that it's collecting a log of information from your program in a sense. It's just another program on your computer that's running, and it's running alongside your actual program, the program you care about that you're working on. And it's sitting there collecting information from your program, and it's really in a log-like fashion. So now there are technical constraints about that, because obviously the debugger has to collect information without modifying the actual program, because it's running with it live and collecting information. So there are limited ways in which it can modify the program. Some of that, varies depending on how well the kernel facilitates that process and stuff like that. But the point is, it's collecting the same kind of information. At the limit, when debuggers can't go too far, you do have to go back into your program and say, okay, now I'm going to printf here and here and here and here, or generate a log, or plenty of other versions of that exist. But so it's not that team debugger versus team logging. It's very much there are no... people should kind of remove that boundary from their heads, because the degree to which debuggers could theoretically do logging is I think more extreme than people, maybe if they're just getting used to the idea of a debugger, they might not realize. So it's not an abomination, although I think it's a lot slower than the tools that debuggers do offer you in a lot of cases. That's how I would put it.
This is hard for my American mind because I only know red versus blue. So this is really difficult for me to have some sort of nuanced answer.
Well, I mean, if you think...
Yeah.
Oh, sorry, go ahead, Ryan.
I was going to say, you can re-slice it so that red is the people who think that there's a red versus blue, and then or vice versa. So you're on team red, which knows that there's no red versus blue, but blue is all the people who do, and then it's just another red versus blue problem. Because I'm American too, so that's how you...
Yeah, okay.
That's how you do that.
Okay, this makes me want to light up a barbecue and eat apple pie.
Yeah, exactly.
Don't forget the Coors Light.
I would never. I would never. Only the finest microbrew.
All right, someone has to have a real question here to kick this bad boy off.
Well,
I would go.
I would keep going on that front, actually.
Hey, Teach, just finished the front end. I'm gonna get the back end in JS. Could you give me the database?
That's node problem. You got it, boss.
That was a mess without type safety. I rewrote our backend in TypeScript. Could you fix up the database? I'm gonna fix the ESLint errors.
Not any problem for me. I got this.
Teach! AI is so hot right now, and my professor's helping us rewrite our backend in Python. Could you get a database up for me?
Certainly, I would love to assist you. You're correct. Let's delve into this.
Hey, Teach. Python scales worse than TypeScript. We're gonna need Go. Could you give me a DB?
Fast, predictable, boring? I'm ready to go.
Hey, Teach, we're shipping a lot of features lately. I know, maybe too many features. I'm worried they don't need both of us. We need to slow down, but we need to look smart.
Are you thinking what I'm thinking?
You don't want your tools to pick your stack? Neon does serverless Postgres. You choose the rest. Get your free plan at neon.com.
So there are some issues, like one of the reasons why I think people like Printf debugging and say, I don't want to use the debugger or I don't see the point of it. There are some valid, like I think those come from a valid place, but they're not actually describing the problem correctly. So the valid place they're coming from is the fact that the debuggers often suck. Okay, so like, like I have complained about Linux debuggers many times, and that is in comparison to Windows debuggers, which also usually kind of suck. Like Linux is like ultra suck debugging, but Windows debuggers historically have also been pretty darn crappy. And so, you know, one of the things that's important to recognize is that debuggers could give you your printf debugging way faster than you actually writing your printf debugging if they weren't sucking so bad, but oftentimes they are sucking. So when I am on Linux, for example, I use printf debugging a lot more, right?
We'll clip it and
a
ship
lot
it.
more.
All we need is Casey saying, I use printf debugging. Don't give the context.
Okay,
We're
sorry.
putting that in a short.
I need it. It needs to be a clean thing.
No,
And the reason for that is because the debuggers are so bad. If I'm on Windows and I have something where I can do my data collection really efficiently because there's good debuggers, largely thanks to Ryan now, but also thanks to the George Menhorn, the guy who wrote Remedy BG, which is a debugger that I've been using previously. When you have a debugger whose user interface and design is set up to get you the information that you need very quickly, it will beat the speed of printf debugging. Because the amount of time it takes you to go add those printf lines, recompile the program, rerun the program, see where it prints out, then go, oh wait, I should have a few more printfs, and then you go back in there. That speed, you can be way faster than that to collect the exact same information with a debugger if the debugger is actually good. Now, if the debugger isn't good, it won't beat that speed, and then I am right there with everyone who's like, why would I use a debugger? Yes, like, you're right, because the debugger is too freaking slow. And so part of like what Ryan's project is with the RAD debugger, for example, is to stop having that choice around. It should just be a given that the debugger will collect the data for you way faster than you could have collected it by instrumentation. But the sad reality is that a lot of times currently it isn't, especially on Linux, but also for certain circumstances on Windows as well. Thank you, Ryan, for actually tackling this problem for us.
So when I say I use printf debugging, that's the exact same thing as saying I use Arch, by the way?
Oh,
It's like very,
no,
very,
I wouldn't
very close.
necessarily go that far. I wouldn't necessarily go that far. I wouldn't go that far.
All right, so Ryan, are you actually trying to provide us a solution, us Linuxites?
Yeah, that's like, so...
Linuxations.
Linuxations, sorry.
Linuxations, right. So yeah, I mean, it's actually like, and if you go back and look at, I think it's on Web Archive at this point, but if you go back and look at the RAD debugger's like original like pitch page where they actually described the project, that was one of like the primary ambitions of the project all the way back then. I think this would be like 2013 or something. And I was nowhere near the project. I was in high school. So I was like not even working on the project. But all the way back then, if you go back and look at what the original ambitions of the project were, it's like, let's get a viable debugging solution on Linux. And so that's still part of the ambition. And that's actually like I'm starting to work on that, not quite full time because there's a lot of stuff to fix and everything. I mean, with a debugger in general, there's like hundreds of possible problems you could work on at any point in time. But I'm starting at this point. It's gotten stable enough on Windows that I'm starting to do more of the Linux port work, and so I have like the UI running, and I'm starting to do process control, and we have dwarf debug info parsing and stuff like that. So yeah, it's actually going to happen. Like it'll show up at some point soon.
Before we go further, I think there's a lot of people who don't know anything about RAD Debugger or Ryan or other stuff. I know we jumped right into the Printf controversy. We wanted the hot take, but maybe we can just take a sec. You can walk us back a little bit. You can talk about maybe RAD Debugger and give people some info of what's going on. Casey's mentioned it like 1,000 times on the channel, so I think we gotta tell people what it is. You know.
And is it Epic Games Debugger now, or is it still RAD Debugger?
It's called RAD Debugger, but that's sort of just historical. Epic bought RAD Game Tools back actually shortly before I joined, so I was never technically a part of like RAD proper. But Epic owns it now, but it's still called the RAD Debugger because I don't know. That's what they just I don't know. Nobody's told me that it should be renamed, so I haven't renamed it. But yeah, I mean basically like the story of the project is. It started with what I said. Like they wanted a viable. To my knowledge, I wasn't even near the company at this point. So
I was there. If you want the actual story,
yeah, maybe you should do the early, and then I can say what happened after.
Yeah. So what happened specifically was, and this'll just show you. Remember the idea of the Steam PC, like Steam Linux. Do you remember this? Way back, like way back. In like the early 2010s, they were like gonna ship this Steam Linux set-top box thing, and it never really materialized. Like some IHVs kind of did, but it never became a thing. And then like fast forward to today, and they redid like sort of a similar plan to that, and with similar people. Like I think Pierre Lou and those guys were same. I think it's like similar team did do the Steam Deck, and that has hit. Like that worked, and they are going with it. But way back there was this sort of idea that they were going to do a Steam Linux distribution. This is where it sort of actually started, because obviously RAD does a lot of cross-platform stuff. They have to ship on Linux as well as Mac as well as XXX. Like in fact, when I worked at RAD, it was dizzying the platforms we support. Like I'd build, the character animation system, and it's just a laundry list of platforms. It's like 14 long or something like that. So that was where I learned cross-platform programming like the hardest way, right? I had a little bit of experience before, but that was the big one. And so RAD and Valve were always historically very close. Like Jeff and Gabe, so the two heads of the companies, used to have lunch pretty regularly. So they were never like at each other's throats at all. They were not competitors really, or never thought of themselves that way because they didn't really operate in similar business spaces. So they were actually fairly close, and oftentimes they would even share employees sometimes. So there would be times, like for example, on the VR projects where some of the RAD people were still technically RAD employees, but like Valve would pay their salaries and they were at Valve. There was all kinds of stuff like that. So it was kind of closer than people know about because it's, there's not like this is secret or anything, but just like, it doesn't get written about or no one cares or whatever. So because that was a very like closely, they talked a lot. There was this idea because Valve really wanted to do Linux stuff, and there isn't great debugging tools that game developers are used to. And again, we also need a lot of specialized debugging tools for debugging things like 3D geometry and this sort of stuff. So we need things like GPU intervention stuff, and we need things like to be able to visualize vectors and all this other stuff that you might not need. So we need ways to add that too. So how are we going to get this stuff? And so what Gabe and Jeff decide is they're going to do a debugger project to get a good debugger going on Linux, and Valve's going to fund some of it, and RAD's going to fund some of it, and it's going to happen at the RAD offices. So they expanded the RAD offices. There's like a new like area that got added on. They like grew and took over a little bit more of the floor. I assume people seem to like when I go on ridiculous story time, so I'm just telling the whole story. If this sucks, you can stop me at any point. You edit it out.
Okay.
It's great.
We love it.
Okay.
We love it,
Yeah.
Casey.
Yeah.
So they
Leave
expanded
a comment on YouTube if you love
I
this.
love the
Okay.
BC. Yeah, I love the BC, and I can't wait for the AD coming up. So I'm
well,
super stoked
Ryan will
on
take
both
the
sides.
AD. We're going to hand
Yeah.
it off, and then Ryan's going to do the AD. And so they had some people there, but it was always hard to get a team of people who actually would like get it to the point like where it needed to be, and largely that was because debuggers are kind of, I guess if I had to describe them, they straddle a really uncomfortable boundary. D's nuts jokes aside, the straddle is very uncomfortable for a lot of programmers if they're have to tackle it sort of holistically might be the way, or head head on. Let's say, if they have to come at it from the front, then this straddle is very difficult.
I just have to say, Casey.
Yeah.
You've been hanging out with us a lot, and I love this.
Okay. I feel like I'm allowed to say these sorts of things here, so I do.
Yes, it's a safe space. It's a safe space.
So, what I mean by that is it's a project that crosses between UI sort of like I need to know how to create visualizations and interactive things that show a lot of information in highly structured ways. If I had to rank programs by what is the hardest kind to write the front end for, it's actually debugger. It is literally the hardest problem that I know of. If you wanted to see if a UI programmer is actually great or just kind of mediocre, have them try to do a debugger and see what you get out of it, right? Because it is I do not know of a harder problem that you would have to solve other than debugging, really, right?
Ryan agrees wholeheartedly. He's like,
Yeah.
you're so right, Casey.
100%. Yeah, totally. 100%.
I mean,
If you can make a good debugger,
maybe you
you can
could
make
argue that like 3D editor, like Blender, because it integrates the 3D part, like
Right.
those are the two that come to mind, and they each have kind of different stress points. Ryan decided to do both by adding 3D visualization to the debugger, so that's where he's at. But you have the hardest UI problem or close to the hardest UI problem on one side, and then you have like system level process control, register inspection, module loading, and disassembly on the other side, which is all ultra low level, right? So when you put those two together, it's really hard to find a group of people who can actually go from zero to debugger. It's really, really difficult. And so the project never really got off the ground because it just didn't have the right mix of people to actually make that happen. I'll spare the gory details of that. But
Can I jump in for one quick second?
as many seconds as you want, it's your show, Prime.
No, it's our show. But
Oh, wow. Oh,
like
my
one
God.
reason.
I'm feeling the love over here.
Thank you. One reason why I've historically keep using Vim and then integrating DAP, debugger adapter
way.
protocol, and then not using it is because the Vim UI just does not feel currently kind of set up for debugger, because I do believe
Possibly.
a debugger UI is a very visual experience. It is not like
Yeah.
it's not just a separate buffers and text. There's more to it, and every time it just feels very clunky. So I agree with you. UIs are like super duper hard to be able to build.
Yes. And debugger UIs, because they have to marshal so much information, and the entire value of the debugger is can it allow you to edit that information display
Yes.
and update and present that information display as smoothly and as quickly as possible. Because there are plenty of debuggers. WinDBG would be a classic example of a debugger that has all the features under the hood and is largely completely unusable 99% of the time. Like, you will only fire it up if you need a feature that only it has, like time travel debugging. Otherwise, it's completely useless because the amount of time it will take you to actually set it up to do the debugging you want, you could have just done your printf, right? Like, it's the canonical example of what we were talking about at the beginning, where it's like anyone who was given only WinDBG and was like, I pretty much only use printf debugging, I'm like, yep, me too. Yep, like, absolutely, right? So, so anyway, the project kind of languished as a result of this. So really not much actual usable work happened between, that when it started in the early 2010s and later. Now, I tried to hire Ryan, full disclosure, out of college. Like, not when he finished college, but while I was in college. I was like, hey, do you want to come work on this? And he turned us down. So that didn't work out. So eventually,
You just wanted him to come on the pod to air the dirty laundry, Casey?
Yes.
Yeah, I love
And
this.
suck it,
Yes.
Ryan! We hate your guts!
yeah.
We hate you!
I came later. I don't know what to.
I love it.
We
No, I
could've
was so
had
I
him
was
on
so
Linux.
delighted. I was super happy, but I was so unhappy then. I'm like, damn it. All right. I should have been more aggressive. But anyway, so we tried to hire Ryan and that didn't work out. But eventually it does work out, and not only do we get Ryan, but we got Nick, and we also got Alan Webster. So like three people I picked. And also, I mean, I guess Martin's never really went on that project, but he was another person I tried to hire and succeeded. So out of those four people, that I tried to hire, we ended up getting all 4. And through some combination of them, then they were basically able to reboot and successfully complete this project. Now it's a totally usable debugger already, even though technically it's only an alpha, and they really haven't been working on it that long, because even though the project was very long, most of it was not actually usable. So anyway, Ryan can now pick it up from that sort of modern era. How did it happen?
Yeah, so I came on board in 2021, and I think Alan, I don't remember when Nick joined, but I think maybe Alan was slightly before Nick, but Alan and Nick showed up, and they were working on, Alan had inherited the project from Juan Chun, I believe. Yeah. And he had a bunch of stuff, and the thing about debuggers is that there's like 1,000 problems. Like, you have to know how to parse debug info formats, everything that Casey was talking about. You need to know how to do process control. Reading registers even is like more work than it might seem like it would be. And so they have
patching
all this
the binary too. Like, you have to be patch the binary for breaks and data breakpoints and all this crap. It's huge.
Yep. Yeah, like even how to implement like line stepping is already like that's a deep rabbit hole already. There was a ton of work done in that direction, and then once Juan had left, Alan and Nick worked together on a bunch of the problems around. I think Alan was focusing mostly on the debugger stuff. Nick was working on. Nick is really good at like reverse engineering, like how the PDB format stores certain things, or how do you do unwinding, in this particular case, or all that sort of family of problems. Nick is really good at kind of drilling deep and figuring out how that actually works. So he was kind of working on that stuff. Alan was trying to work through the problem of like, how do you actually build an architecture for the actual debugger sort of engine, if you will. And then I joined, and my role initially was sort of like, I was helping with a bunch of the debug info parsing stuff, but I was going to build the UI. Like, that was the end goal. Like, I would be on the UI, like the front end side. Alan would be doing the engine. Nick would be doing like debug info format parsing, unwinding, like figuring that stuff out. And for a while we were just working on debug info parsing. So that was 2021, and maybe 6 months in or 8 months in, I switched over to building like a little prototype debugger just so I could like familiarize myself with the problem space. That has been like thrown away. So that's no longer in the code base, but it was just like a really crappy little like, let me figure out how you even do things like stepping. Like, how do you actually specify how a step is even supposed to happen? And then Alan worked, the last thing he worked on before he left was we also have a custom debug info format. So both PDB and Dwarf, one of the problems you have to deal with debuggers, especially one that tries to ship to both Windows and Linux, is you have to deal with like the situation of the different tool chains. One of the realities of that situation is that these two different tool chains use completely different debug info formats, both of which are extremely complicated, and they're very different in how they actually organize and slice information. And so we had kind of always talked, at least I'm sure they talked before I even got there, but while I was there also, we were talking about like, this debug info format problem is really difficult to deal with, actually. And so if we could actually move to our own format instead, and if you start with PDB and Dwarf, you can convert to our format and then build the debugger on that, and then it works everywhere. You don't have to deal with like an abstraction layer, for example, over incrementally parsing Dwarf or PDB. It gets really nasty really quick. We tried to do that, and then it turned out to be really complicated. And so the last thing Alan did was he designed the first version of that debug info format.
We should mention Alan's not there anymore, so that's why it's like the last thing he did, because he left shortly after that.
Yeah. So, and then at that point, once he left, I was building the UI for the debugger, and then I just sort of took over the pieces that he had written, and I either took them over, rewrote them, or they kind of like dissipated because it's just as the system evolves. If there was a layer that he wrote that I wasn't familiar with, I was like, I'm not really sure what to do with this, so I'll rewrite that part or whatever.
Understanding through replacement.
Yes, exactly. So I kind of, at that point, I took over most of the debugger stuff. Nick actually works on a linker. This is another very deep rabbit hole we could get into. So Nick works mostly on the linker, but he still does a bunch of he built the Dwarf format to our debug info format called RDI. He built that converter recently. It's still early, but he did like a first pass on it. So he's working on problems that overlap with the debugger, but he spent most of his time over the past like year or two, maybe a year and a half, on the linker. and then I've just been on the debugger. So, and I guess that's the story of the project. What it actually is it's a graphical debugger that you can debug your programs with.
So one thing that I think people... So one of the things that I was literally complaining about on Twitter just recently was people are like, well, game programmers just don't understand all like the real problems that banking people face or something like this, which is one of the most absurd things I've ever heard, and I'm really sick of it. But like, just to underscore how like much that kind of thing is ridiculous, I have not ever actually heard of any other project besides Fortnite that hit the limit of PDB.
Yeah.
So the literal output of debug information on Windows, Fortnite got so large as a project, it could no longer be built because the debug info could not be stored. I just want to...
There's a file limit size, right, that
yes.
exists on Windows. So if you
no, it's not. It's not a file limit size on Windows. It's a file limit size in PDB. The way
it's like
that
one of the sections.
Yeah, one of the sections.
They use 32-bit. Yeah, they use 32-bit offsets. Actually, they use signed 32-bit offsets.
Yep.
Into it's like one of the type information sections. And so once you get enough types, and especially once you're doing like heavy C++ template metaprogramming or lots of Lambda functions, those generate types. Every single one of those generates types. And so you get this just massive expansion of type information.
Yeah.
And then you run out of that space like pretty quick once you're at
So JP Morgan, call me up and let me know when you had to write your own linker because you exceeded the PDB file size. I'll wait.
I was wondering, though, like, Ryan, which collab was it that pushed them over the limit? Was it, like, Star Wars, or was it, like, which one was the...
That's a good question.
You know, oh, my goodness, we had been all the Star Wars characters. Oops, it's the Pokemon collabs. You know, we gotta make sure it's got all the Pokemon.
You know, I think it might have been the Snoop Dogg skins, like, when they added the Snoop Dogg... You know, Doggy Dog skins.
Yeah.
That was like this is too much.
It was when they stored all the Darth Vader voice lines that got them in trouble, right?
Yeah.
Well, Sabrina Carpenter lyrics, they don't get compressed very well in the PDB, so the problem is like that and it was a problem, and it's fine.
But are most of the songs like six different words? So
they just don't compress very well because they're so creative, Tej.
Right.
Yeah.
Oh,
Tej.
got it. Sorry.
They're practically white noise. They're so creative.
Yeah.
They wanted to compute them at compile time too, so each lyric word was a template instantiation,
Yes.
and so that's why there's so many types.
Yeah.
That makes sense. That makes sense.
So, long story short, there are some pretty cool things about this that, if you read between the lines, are there that's really awesome, and I think will be very, very interesting to people going forwards. One is RAD did release the linker, which means that now, if you want to bypass the entire crappy like Microsoft and or Clang linking scenario on Windows at least, and eventually presumably Linux, you can. You can have a much faster linker that produces RDI. Is it RDI is the name of the file type or something?
Yeah.
Directly.
Yeah.
So you can have that debug info, which is more efficient to use and much more like well documented and like this is easy, it's easy to kind of get into. That's pretty awesome. But two, those RDIs also now there's like this convenient sort of thing you can look at where it's like, here's a code base. If you would like to access the debug information for your own programs, to write your own instrumentation tools, your own inspection tools, your own metaprogramming tools, whatever you want, now RAD has done that for you, or Epic has done that for you, right? And so this project has a lot more cool stuff in it than just the debugger because they chose to tackle a bunch of other hard problems at the same time and succeeded.
I got a question for you, Ryan. As someone who also worked at Epic but a different one, how often, like on a weekly basis, after you tell someone you work at Epic, do you get, whoa, bro, that's epic? Every time, like, because I feel like you're like, guys, come on. Everyone said that joke already. You can relax.
Yeah.
You know?
It definitely happened. It's funny because I was wearing an Epic shirt to a hospital at some point.
Oh, they thought,
yes!
And they're like, hey, can you help us with this quick? Like, bro, just like fix my chart problems really fast.
Yeah. And like, it was one particular shirt design where you could see Epic very clearly from a distance, but you couldn't see the games part very clearly. And so they were like, oh, Epic, yeah, we use Epic here. I was like, don't tell me they're putting Unreal Engine like in the MRI machines or whatever. Like,
it's a brand new therapy. We put them on Fortnite. It's like the days go so fast. Before you know it, you're healed. You know, it took 6 months, but
all the surgeons are like flossing in the room, like they're like doing stuff, and you're like, what is happening? And they're like, it's an emote. Sorry, don't worry about it.
They
Right,
always
but I do-
emote after a surgery.
Yeah,
They're like,
yeah.
crushed it, bro.
Yeah. New heart. Closed up that valve.
All right, so I have a pretty serious question. Since you do work at Epic, do you get free Fortnite?
Isn't Fortnite already free?
Yes.
I don't know.
The Sabrina Carpenter skin. Can you get that for free? Is what he's asking.
Just asking for a friend, okay?
I see. I haven't tried, but I can check for you. I'll let you know.
At my Epic, they had my favorite phrase, which was consider your salary a stipend for that. Like whenever people are like,
Are you kidding me?
Why isn't gym membership included in our paycheck? Right? Because like that's the big tech thing to do is like,
Right.
we're gonna micromanage your life and give you $100 extra a month to pay for like a gym.
Right.
And
Right.
I loved Judy on stage, like 12,000 people answered at one time, like consider your salary a stipend for that. And I love that so much. I was like, yes.
They're like,
Yes.
what do you think we are? Some kind of healthcare company here?
Well, they did give really good health insurance. I missed that after I left. They were like, but yes. But it was good.
They probably just hack into like it's running all the systems. It's just they set all their employees to $0 every time, right?
Yeah.
It's like we're
Insurance companies
providing
hack it.
health care.
Zero. Yeah.
Oh yeah, the other thing about the Epic misunderstanding, TJ, is not so. You probably don't have this side of the problem. So they're like, oh, you work at Epic, and it's like no, not that Epic. The one who makes like Unreal, and they're like, oh, that's Unreal. So there's like two words they can
back
say.
to back.
Yeah, exactly.
Dang.
So that gets rough. But
I just had the look of like intense sadness when they found out I didn't make Fortnite. Like the only thing they thought they were going to be able to connect with me on. Like I'm a software developer. I work at Epic, and they're like, oh, cool, something interesting. And I'm like, no. Electronic medical health records, and I work in an insurance and billing section.
Yes.
They're like, well, that's kind of cool too. It's like almost like making the world's biggest video game. It's almost there. What language do you write in? Oh, MUMPS. The conversation's over.
I did a little bit of programming in college. What is it? C++? C? Oh, mumps. Oh, okay.
What the hell is mumps?
That's the language that they use at Epic. Oh, that's right, Casey. You weren't there for when we
The
talked
hell
about...
is mumps? That's a
It's a
disease.
disease.
Why is a healthcare company programming in a language that's named after a disease? What the hell is happening?
Casey, but this is like, why do programmers think of dumb names? Because they're stupid.
What is
like,
mumps? Tell me. No, I want to know what mumps is though now.
It stands for like Massachusetts University Multi-Purpose System or like something like it's like they made it at some hospital in like the 70s or something like this. I don't remember exactly.
All right.
And so they don't call it mumps anymore for exactly this. They call it M. But it's
That's
mumps.
not better.
They just call it M.
That's very confusing.
Well, yes,
What
Casey,
is
but it's
James
better
Bond
than
now? Like it's like, that's Q and that's M.
They also skipped like D, E, F, G. Like they started at C and now they're at
Okay,
M. It's
yes,
very
but
confusing.
guys, there's trade-offs. The option is presenting the doctors with this was built with mumps or this was built with M. Okay, they're gonna say something. Fine. Sometimes they say InterSystems Cache because that's one of the people that provide it. All right.
I would just like to point out that basically all of the D language stands out there are now furious at Prime for saying they skipped D. Wow, that's gonna hurt some people.
Dude,
at
all
Prime.
Hey,
one of them.
Wow.
Yeah, all 7 of you in the comments, let us know that you've written a line
God.
of D.
Oh my God.
Wow. Oh, we have
Brutal.
garbage collection and manual memory management. Oh, but you don't have users, okay?
Yeah.
So
Hey, what's one thing that both C++ and Rust users can agree on? D sucks, right? Like it's very, very simple.
Oh my God, you guys. All right, I'm not involved in this. This is nothing that I don't wanna
Casey.
have a fight with D people.
we're cutting that out. We're putting the whole thing in here, and we're putting in a you laughing. We're just going to splice you out of context.
Oh, yes.
I should
Casey,
never have let you guys have edit. You
do
should
you-
never have been able to edit
Do
these.
you actually know anything about D?
Me?
I do, yeah.
Yeah. You can
A
just
very
say
little
what's
bit.
D.
A very little bit.
You can just say that if you need to.
What?
Casey, but explain this then. If you're such a big fan of D, then why is it not demoratory?
Yeah. That's
I'm not a
great
fan of
question.
D. I'm just saying, like, I
Oh, we
didn't.
got him! He's not a fan of D. Cut it.
Oh my
Slice
God.
it up, boys. Put it in.
All right, well, thank you, D. Moratory, for that. You know, I'm not going to lie to you, Ryan, you've been suspiciously quiet about Oodle. Could you please explain why you haven't talked about Oodle once yet?
What? He doesn't work on Oodle.
Yeah, I don't work on it.
Obviously, you'd use the compression in all of your debugging, so I would assume so, at least.
I don't actually, like, the only thing I use like one header file that Jeff gave me for compressing, but I don't even think it's any of the Oodle stuff.
Okay.
It's just so I'm very Oodle adjacent, if you will.
Do you want to talk about Oodle Prime? We
No,
could
I
ask
don't,
Charles
actually.
or Fabian. Okay, I'm like, they would come on, probably. One of them might. I don't know if you want to talk about Oodle. But
I just wanted to ask an Oodle question at some point, okay? It was very important to me because it's such a funny name.
Okay, we'll do an Oodle stream next time. This time, though, could we talk about debugger information stuff? Because I'd like to talk about that.
I actually will. Can I do a real follow-up question?
Please.
You said something, Ryan, inside your talk, which is how do steps work? And I thought the same thing. I'm like, how do magnets work? How do steps work? And so, can you explain why that's such a tremendous problem?
Yeah. So I don't know what a magnet is exactly. Maybe.
Yeah, no one.
You
does.
don't have to answer that one. It's
Yeah,
not possible.
This is not going to be. We don't want this to become a Christian stream right now, so please don't answer that question.
They don't know the reference, Prime. They don't know the reference.
No, he does know the reference. That's why he said that.
No, I don't think he knows the reference.
Take a look at this fine creation and enjoy it better with appreciation.
I don't think I know.
Magnets work. He doesn't know. That's fine. Neither does chat. Move on.
Okay, got it. Okay,
we
I think
killed him.
that.
That was the perfect response if you did know, though. That was, like, so good, because we don't know how magnets work. I mean, no one does, right? That's the whole point.
Yes,
I see.
thank you, Casey.
I see.
All right.
Okay,
All right,
so
let's
I
get
can
off
explain
theology,
how.
Let's get back to this. How do steps work?
Okay, so line stepping is. Okay, I guess the first thing to understand about the problem of stepping is sort of how a debugger interacts with like another running program in like another native running program on an operating system. So basically the debugger has the opportunity to like make changes to memory and make changes to registers, and then it can suspend or resume certain threads. Like you can basically set up certain threads to run or others to not. And then it just says go, basically. It can just say to the operating system, okay, now you can schedule this program's threads again. And then, like, the debugger loses all control at that point until that program does something that would cause the kernel to transfer control back to the debugger. And so if you think about what it actually means to, like, step over a line of source code, first you have the problem of, like, locating where where a thread's instruction pointer, because you're stepping a thread over some line of source code that it's on. First, you have to like extract the register value that stores the instruction pointer of whatever thread you're stepping. You have to then understand where that actually what source code that actually maps to. Once you know that, you know the range of addresses that are associated with that particular line of source code that thread happens to be stopped on. And then you have to say like, let me, basically I have to produce the effect that this thread will stop execution, like the program will stop execution when this thread leaves this line of source code. Now, a very naive algorithm you could do to do that would be to say there's something on CPUs where you can single step a thread, which at that level it's just stepping over one single instruction, and then it immediately interrupts. So you can basically set a bit in one register on the CPU, and you can say, okay, step over one instruction and then stop.
Can I interject one thing real quick here for the folks at home? So just to be clear for anyone who hasn't looked at this kind of thing before, so when you have a line of source code, a compiler is turning that into potentially many assembly language instructions that will actually be executed by the CPU. So there's this mapping, and not only is it a like one to potentially many mapping, meaning one line of source code could produce many assembly language instructions, but also in more sophisticated builds, like when you're running an optimizer, those assembly language instructions do not occur in a chunk. So it's not like going from one to like 3 instructions in a row. It could be going from one of your source lines to several instructions peppered throughout other instructions it has been mixed with that come from other lines of source code, right? Yep. So the mapping is very messy, and one of the reasons that debug information is not a super easy problem is because the whole point of that thing that Ryan was talking about before with PDBs and dwarf, like this debug info that gets produced when you build your program, one of the reasons that's so messy is because that is trying to store in some way that a debugger can use, among many other things, how do you go from a line of text that the user typed into Vim, right, to which assembly language instructions the CPU is going to execute, which ones it caused, because when you're going through an optimizer, it's combining instructions, it's like removing instructions, it's reordering instructions, and so even just that one part is messy. So everything's Ryan's talking about now when he's saying how do you go from one to the other, like just keep in your head that it's a very messy mapping between those two. That's all I wanted to throw in there.
I had to also throw in just a quick question to answer along the way, which is when you breakpoint or you hit some sort of stopping condition and you're in the middle of a line, does that ever happen as well? Like where you're just like, I'm halfway through a line, what line do you appear on? Does that screw up debugging information that causes confusion? I'm very curious about that.
Yeah, so that definitely does happen, and it can even happen, like, for example, if you step out of a function call, like you're inside of a function, you want to return to whoever called you. Generally, like, there might still be some instructions to execute after you've actually popped from the call, so if you do a step out operation, you'll end up in the middle of the line. You're not just at the first address of the line's source machine code. You might be at some instruction in the middle. And so basically, that's just an extra wrinkle in the problem. You don't, it doesn't really screw anything up, but you just basically have to say, like, this is a range of instructions, and if the thread ends up anywhere in here, I have to associate that with this particular line of source code. So it's one detail in the mapping, but it's not like a showstopper by any means. So yeah, if you wanted to step over a line of source code, if you wanted to, like, basically proceed this thread until it has exited this particular line of source code, you, one simple thing would be to single step that thread until you see it has left the line. Like, you just keep mapping the instruction pointer every time it comes back. And then if it leaves if it's changed the source code line that it's on, then the step is done. So that's a very simple algorithm. It also is enormously slow, because remember that each one of these interrupt instructions that comes back, each one of the single step, after a single step has completed, basically what's going to happen is the kernel is going to schedule that thread, and it's going to say, okay, execute one instruction. It's going to immediately trigger an interrupt. The kernel will then, it'll switch to the kernel, and the kernel will say, okay, now I need to report this debug event to the debugger, so it has to transition, it has to context switch over to the actual debugger itself. And so every single time you do a single step, it's one of these round trips. You can think of it as between the debuggee or the target process and the debugger itself. And so if you've got a line that has 100 or 1,000 instruction, I mean, you know, you can make it arbitrarily long, really. You know, you're causing a round trip every single time someone every single instruction within that line. So that gets very slow. So instead, what you kind of want to do is say, like, I'm going to set up a bunch of, there's another concept that I should introduce, which is the int3 instruction on x64, but there's equivalents elsewhere, where you can basically put it's a 1 byte instruction that you can use to overwrite any instruction, basically, because it's just 1 byte. So it's the minimum instruction size. And you can go ahead and say, I'm going to put this here, and then when the thread executes this instruction, it's called an int3. And when it, there's other kinds of interrupt codes, but int3 specifically is this 1 byte instruction that you can put anywhere in the code stream. And when a thread executes that, it'll immediately interrupt. So it has the same effect, sort of, as the single step, except it's caused by an instruction you put in the code. And so then so in order to avoid all of these round trips, what you can start doing is saying, when the thread is in this line, and I say step over this line of code, I'm going to basically set up an int3. It's called an int3. It's also called a trap, is what people call it. So what you can basically do is start putting these traps anywhere you think the thread might go within this line. Now, if it's pure linear code, like it's going to do a bunch of mobs and then an add and then, you know, whatever, very simple linear code, there's only one trap you actually have to place, which is at the beginning of the next line. But it starts to get more complicated if you, for example, if inside of that line of source code you've got a jump instruction or a call, then you have to start thinking about, like, where are all the places this thread might actually go to? And so then you might have to start doing things like, okay, let's disassemble the line, let's figure out, like, where the control flow will lead to in this line, and let's go place traps in all of those places. And then it gets a little bit more complicated too, because, for example, if you're in a recursive function call, like, so two variants of stepping exist for people who haven't used debuggers. There's step over and step into. There's a lot of other steps you might imagine doing, but those are the two like common ones. And step out. Step over will basically it won't follow call instructions. So if you do a step into, you're sort of stopped at a function call and you want to go into the function call and see what's actually happening inside of the function call. With a step over, you don't care about what's going on inside the function, so you just want to step to the next line and have whatever happens inside the function happen. Now, if you wanted to do a step over, you could imagine if you are in a function that is recursive. And remember, a debugger has to deal with any code that someone could write and feed into it. Like, it has to kind of handle all these cases gracefully. There's lots of recursive code that exists. So if you're stopped at one particular line and it's a recursive call into the same function, it gets more tricky because if you just place a trap at the next line and then you try to step over, you're going to hit that same trap address, but in one layer deeper in the call stack. So you basically have descended to the next call, hit the same trap, but it wasn't actually a step over. Because the step over, it didn't step over the line, it didn't step over all of the call work that happened. Now you're one layer deeper in the call stack. So there's no way anymore to actually step over that line of code. So you have to get tricky about like, okay, has my stack pointer changed? When do I update which value of the stack pointer that I want to check against? It becomes kind of basically like a little program you have to send down and say, like, if it hits this trap, do this, and if it hits this trap, do this, and if it hits this trap, then single step here, and like it becomes a very complicated sort of state machine that you actually have to implement.
So hold on. Can I get one more? Oh no, TJ wants it.
I just got just a quick question. I was just wondering, like, on average, what your step count is every day. You know what I'm saying? Like, because for me personally, like, I don't know if this makes me a debugger, like a step debugger or not, but like, I've got my own like walking treadmill now at my desk.
Yeah.
So I didn't know if this is kind of like what scenario this kind of goes on. So I just didn't know how this related to debugger. Does this make me a step-driven debugger? Like if I'm reading...
you're stepping into, you're not stepping over. So we're talking about stepping over right now, TJ.
Yeah. Okay, I'm trying now.
There you go.
See,
yeah,
like I'm trying to step over.
That's the harder one to do.
Which one is harder? How do I do recursive treadmills?
You're on an int3 and it's inside
you put that
stack.
treadmill on a treadmill.
Oh, that makes so much more sense. And then
Yes.
it's running too.
Yes, exactly.
Right.
I got it. Okay.
Okay.
All right.
Prime.
Anyways, you can continue now. Thanks.
Yeah, okay. TJ, how long? Okay, now we have a sub question. Now our stack has been pushed. TJ, how long have you been waiting for that? And also, you have just a black square in your screen.
So
I saw you raise it like 10 minutes ago.
Immediately after we started talking about step stuff, I put it into standing mode, and I was getting ready. I had to set up that scene. I did not have the video thing ready before this. So I probably heard about 5% of what Ryan said, but I was so excited for this joke.
Wow. Okay.
I was so excited for this one.
That is some serious professional level podcasting. All right. All right.
So when it comes to stepping and putting in all these int3s, do you also have like, because I don't precisely understand how jump instructions work. I believe there are relative and absolute ones. Does that mean you also have to update all the relative instructions around all these places that you put these int3s? Because theoretically you shifted down some amount of the assembly.
So
you're not inserting.
Okay, yeah. I thought you were dynamically at like runtime being like, okay, like they're stepping next. Let's actually insert some stuff into the program.
You're overwriting it. You're over. That's why it's crucial that int3 has a 1-byte version, because you're romping it over the instruction. One of the things Ryan didn't mention, because he had to mention like 8,000 things, because this is incredibly complicated, is that actually when you put that int3 in there, you have to remember which byte you overwrote, because once you are done stepping, you have to go replace all of those with the bytes you overwrote. So that happened as part of this process.
Oh my gosh. Okay, so does that mean when you literally overwrite assembly, and then when it hits that int, you then have to put back in the correct assembly so that when it executes the line, it correctly executes the line?
Correct.
That's crazy, dog. That's crazy.
I don't know. It sounds like probably debuggers, it's as easy as making a regular CRUD app, guys.
Dude, have you seen a banking app, though, Ryan? Do you have any idea about a banking app?
Yeah.
Yeah, I can't even imagine. It's just...
That's like magnet level stuff right there.
How do banks work? Actually, we don't know.
Actually, if you would have been paying attention to Twitter, Lori Wire just tweeted how AHC works, which is literally FTP. So
yes. All right.
We
there
do
you
now
go. Cutting
know how
edge.
banks work.
Yes, we do. That's why anyways.
So
I'm not gonna get distracted.
underlying all of this, right, is like this is also why you may have noticed there was a little snippet of Ryan at the Better Software Conference doing a little thing with Wukash where he asked him like, what was the one OS feature that you would like to have that you don't have right now? And Ryan said, I would like to have user level int3. And it's like, what is that, right? And that underlies this entire thing. So what happens is, in the CPU, right, there's this thing called the interrupt table, or there are things called interrupt tables in CPUs, right? And the reason for this is right at the beginning. This is in like 8086. Like the original 8086 chip has this. This is not like a new thing. They've been upgraded over time to have different capabilities, but generally speaking, this exists for a very long time. So they have these tables because what you often want to do is you wanted to have some kind of like higher level supervisory system level, should I say lower level code, operating system code, whatever. You want to have some code that you can trigger from anywhere instantaneously, meaning you don't have to like know in advance that you were going to use this code at this time. Right? A call is when you know you were going to use it. At this point in the code, I call this function, right? This is like, we have no idea what we're going to do. We just suddenly have to do it. And one of the big reasons for this originally is like servicing hardware. So the CPU has to read something from some bus on some hardware, you know, like the original keyboard input or whoever knows what's happening, right? And so what would happen is an interrupt, literally the reason it's called an interrupt, int3, interrupt 3, an interrupt would happen that stops the normal execution, what the CPU was doing. It looks in a table for what it should start doing, it goes and does that, and then it resumes back to wherever it was in the program. It's literally what it sounds like. It's an interrupt. And this was used for doing things, like I said, like reading hardware and stuff like that, because bytes would like come into the CPU that it had to like look at right now. So it would stop the program, you know, this is back when you didn't have multiple cores or anything like that, right? Stop the program as it's executing right in the middle of whatever it's doing, go service this interrupt. It's called servicing the interrupt, right? Go jump to that code, do it, right? So what an interrupt really is it's basically, it's the same kind of thing as a function call, but it's one where you didn't know what was going to happen. It's a function call that happens out of nowhere. And the reason that this is very useful for something like debugging is because one of the things that a function call will do, right, is it's going to save what the instruction pointer was before it does the call. So it will put the instruction pointer onto the stack, right? This is a call instruction. We'll put the instruction pointer onto your program stack. It then transfers control over to whatever the location is you're going. So it changes the IP to point to whatever the function is that you wanted to call, does that, and then when it goes to do a return, it will pop off the stack whatever that instruction pointer was. So it's basically a thing that uses your program stack, your standard program stack, to track where you are in the program. That's a normal function call. An int can't do that because it doesn't even know if there is a stack. It's happening in the middle of any code. There may not even be a stack frame. You may not even be using the stack pointer as a stack frame at that time, technically, in 8086. So what it has to do is do some special work to preserve, right, like the IP in this way that will, like, we know we can preserve just what the instruction pointer is. Then we're going to go into whatever, we're going to look in this special table that the CPU literally has a hard-coded register that tells it where it is. So it's separately stored, right? We're going to go there, look up where we should go. And by the way, nowadays, we also look up a bunch of information like whether we should be transferring control to like a different level. Like, should we be dropping down to ring 0 from ring 3 and all this other stuff, right? So there's a whole bunch of crap in that table. And off you go. So the way debuggers are written currently, because they have to be, is on something like Windows, they are written as a user-level application. Which is fine, because that's roughly what you want. You don't want your debugger to crash to take down your whole system, right? You don't want CrowdStrike happening here, right? So you want the debugger to be running at ring 3 on Windows so that it's running up like a normal program, and if it screws up, like if Ryan on like the one bug he has, right? If you hit that bug and it crashes your system, you just want the debugger to crash. You don't want your whole system to blue screen. So it's good that it's doing this. But the problem there is it needs to do all the things that Ryan just says. It needs access to the memory. It needs to be able to put in like these things like int3s that will happen. And the problem is when you are at user level, right, the kernel doesn't want you doing stuff like messing with the interrupt table or, you know, saying that you're going to be the person who gets whenever an int3 happens in this on this core, that you're the one who's going to get it or whatever, right? It didn't want any of those things for security and stability reasons. So as a result, the debuggers have to do all of the work that Ryan described through an API that the kernel will then use. You know, it takes your API calls and goes, oh, I see. You wanted me to tell you when this guy hits an int3. So you go, you know, I'll let you access his memory through my memory mapping APIs. You go, you poke it in there, you poke your int3s wherever you want, great. When the int3 gets hit, the kernel's the one who's going to get called, not the debugger, and then it's going to go through the API to let the debugger know that it happened. What this means is that now all of these things Ryan's talking about, every one of these traps that gets hit, is a full round trip. Debuggy is running at ring 3. The trap gets hit, the int3 gets hit. It's got to drop to ring 0, wakes up the kernel. The kernel goes, wait, what is happening? Oh, right, this is a debugged executable. I know I should tell the debugger about it. Okay, let me re-switch the task over to the debugger's context. Let me wake up the debugger in ring 3 and resume execution of a debugger thread to handle this. The debugger then goes, what just happened? Oh, the kernel told me I hit a trap. All right, let me go fix up the trap things. Let me set any new traps that I need, and then let me retell the kernel back at ring 0 to resume the debuggy. Back we go to ring 0, it then switches in the context of the debuggy, back up to ring 3, and we resume where we were going, right? This is wicked frickin' slow for so many reasons, right? And so what Ryan was talking about is, hey man, what if we could just set the int3 to just jump to something in the actual, the person who's being debugged, that program? The debugger could like JIT compile some code that just does the trap operation that it wants to do and resets whatever it needs or anything else, right? Checks conditions, anything it wants to. We just set the int3 to not do any of that. Don't tell the kernel, don't take a rin transition, just jump right to that thing, do the stuff, and then resume. It would be so much faster. Getting rid of that, like, first ring transition, back up ring transition, back down ring transition, back up ring transition, right? It gets rid of all of that. So that's what he was asking for, and this would be like a huge feature. If there are any kernel devs out there watching, please add this. User-level interrupt handling like this would be so useful. And then that thing, if it actually wanted to do that huge transition thing, can just have a syscall that it does called actually transfer control to the debugger, right? So anyway, whole big thing of coolness there. We can't do
All
it.
I got from that is horse and debuggy is slow. That's what I got, Casey. So,
I tried so hard, Ryan. I tried so hard.
TJ also tries hard. That's the problem.
Sorry.
Anyway.
Yeah, like what example of, so at a high level, what you might imagine doing in a debugger that uses, that sort of where you want that kernel level feature would be if you set a breakpoint on a particular line of source code. If you like run your program within the debugger, you say stop here. That's like reasonably fast because those two transition or three or four transitions actually. You pay that cost once, and at the scale of like, oh, run to this line, it's not really noticeable.
And you wanted to come back to the debugger anyway, so it's like doing what you wanted roughly, right?
Yeah. So when that gets when you actually really have to pay that cost to a sort of prohibitive degree in many cases, is when you wanted to say, stop at this line of source code, but only if this condition is true. So conditional breakpoints are like super common debugger feature. And it's like kind of the first version of fancier stuff that a debugger would want to do. But this is where it gets really slow, because then basically the debugger can't like do this installation of code that checks the condition inside of the debuggy. And so what has to happen is it hits the int3, controls transferred back to the debugger checks the condition, it evaluates some expression, it like does whatever evaluation stuff it needs to do to check the condition. And if that condition is false, then it goes back to the debuggy. And so if you imagine you put this in a loop that's supposed to run 1,000,000 times, maybe it happens instantly, normally, but because you're paying this round trip cost every single time the thread hits that int3, it just becomes like prohibitively slow. Now, if you're doing it once per frame, like it's still worth it for debuggers to have conditional breakpoints today, but they're like dramatically pessimized just from this problem. But if that problem were addressed, you could start doing lots of other things. Like Another thing, something like printf debugging, is profiling, like inserting profiling markup in your program. Like if you wanted to say, oh, I want to sample the time here, let me measure that, build me a flame graph of this kind of thing. That is the same problem as print debugging, where it's like, okay, go back to the source code, insert the things that I was looking for, build the program, run the program, get back into the state that I wanted to be looking at, and then inspect the log. And then it's like, oh, I need to drill one layer deeper into this like flame graph here, but I didn't add the markup there. So let me go back to the program, add the markup there, and you can't do it too much. You can't do it at every function, for example, because then that profiling cost will start adding up like dramatically, and then you won't even be able to see what the actual performance costs were. So what the debugger could do is like, let's just do that dynamically. In the debugger, let's say, add a line of markup here, like a sampling line here, add a sampling line here, and then it could gather that data completely dynamically. It'd be way faster to like drill down into problems when it's really uncertain what you need to be looking at, basically. So yeah, that's like the high level, what you would expect as the user if you had this kernel level feature, basically.
Yeah. And so what we have to do now, basically, right? If you want to do this kind of thing, you can still do it. But what you have to do now is you have to handle a crap ton more edge cases, basically. So what happens is, if you want to, you can still do effectively this by not using int3, right? Because remember, the important part about int3 is it's a 1-byte instruction. So even if it's overwriting another 1-byte instruction, it's okay. All the code will still work exactly as it should because you only have the int3 just exactly where it needs to be. And anyone who's like jumping to the byte immediately after that, doing something weird or who knows what, it's fine, right? However, if we wanted to implement a feature like this without the assistance of int3, or halt or any of the other instructions that go through a table and are 1 byte, right? There aren't very many. I think there might only be those two. I don't know if there's a third one, but anyway. On x86 anyway. So if you want to do that without this, and Ryan has looked at this sort of stuff, and this is the kind of thing people are currently doing, so this is how you have to do it, you have to input some kind of a jump or a call actual instruction there, which takes more than 1 byte. So you can still do everything we just said, but you have to overwrite the thing you were going to overwrite with several bytes, potentially. And when you do that, now you run the risk of, if those several bytes overflow and go into the next instruction, that could have been instruction that someone was jumping to. So now we have to do all this checking to figure out, like, is someone jumping into the place that we had to overwrite to, and blah, blah, blah. So now what should have been a very straightforward extension of just patching in an int3 and everything works perfectly, and guaranteed no problems, what should have been a perfect extension of that is now this huge, like, did we catch all the corner cases? Oh, crap, it doesn't work in this one place. And now we got these bug reports from these guys who were doing this thing. And, and so if the kernel could just add this feature, all of that complexity goes away. And there's, like I said, so this is a thing that people have done. It's not like you can't do it. It's just it turns what would have been a very simple problem into a very complicated problem. And so that's why it would be great if the kernel could do it.
Kernels are great at that.
Yes. That's why we call them kernels, because they're like a kernel in a military thing where they... I don't actually know.
I like it. Casey, keep going.
Yeah,
we'll cut it out in post.
Where does the kernel keep his armies?
Shoot for it again, Casey. Here, it's like the kernels are great at that.
Yeah, just like we're gonna take it, mate. I beep. Yeah.
So are all these things you're describing effectively gone in things like JavaScript or in any interpreted language which has a VM? Because then the VM can go, well, I can just insert an interrupt like right into the bytecode. I don't even have to worry about it since I'm processing these things. Do a lot of these problems effectively, because the Chrome debugger is actually shockingly a great debugger.
Well, okay.
Well, I mean, you got to remember you're debugging JavaScript. There's not like a lot, it's
I've had a lot of I've been not that happy with its accuracy in catching breakpoints and things like that, actually, so I would not categorize it as a great debugger personally.
Really?
I would say it's a pretty mediocre debugger in my opinion.
You don't even program JavaScript. Don't even try.
I do. I've programmed a lot of JavaScript.
I already know that this is a trap. This is an int3. I am not getting bamboozled here, Casey.
I have used that debugger a bunch. I had to use that debugger on Electron even prime. So I used it locally.
That might be different though.
Local Electron fun, and that was a huge ball. Like that was great.
Yeah,
that
might be different. I'm not.
It's not. It's the same. Yeah. But I've used both of them. Yeah. I feel like it is not reliable. It's not reliable on a couple things. restarting and catching breakpoints when a web page is reloaded, I have found it to be fairly unreliable,
Yes.
actually. And that's a very important thing, because if you're trying to debug stuff that happens at startup, right, like at load time, it just, and so, you know, it's one of those things where when you use a debugger, you get this feeling of, is it solid or is it not solid, right? Not
I think I know
the
exactly your problem.
SOLLD
Okay.
like acronym SOLID thing, not Liskov substitution principle, but like, is this thing reliable so that if I set a breakpoint, I know for sure that this code only got executed when the breakpoint got hit and no other time. And I definitely can guarantee you that was not
I think
true
I
of
can
the
actually
program.
explain that one. That
Okay.
one I think I can explain, because if you use the keyword debugger inside JavaScript, you'll actually get it every single time. But if you use the actual Chrome debugger to do that, it uses the CDP, the Chrome debugger protocol.
Okay.
And so it has to do some sort of async communication with your process, which if it loads fast enough, you're going to miss that entire plane. Is what I'm like 99% sure that's what's happening, because I've ran into a bunch of these issues.
Okay.
Working on that protocol.
Oh, so
on
now
various
you
things.
run into the issues, Prime. At first,
Yeah.
Casey said, yeah, okay.
It
What
is
else
a great one if you use it correctly, right? I mean, come on.
But that you shouldn't have to, right? The point of a debugger is to save you time. If I have to go research why this thing can't set a breakpoint, it's like, oh, the thing that's supposed to set the breakpoint, you don't set breakpoints that way. You have to use this other thing that's not how you
Idiot.
set a breakpoint to set a breakpoint. Like, then that's worthless. Because again, I could have just done printf, which by the way is what I do. I do console.log when that kind of thing happens. So this is why I say I totally understand people who like go, I don't use debugger. It's like, yeah, because when the debugger is unreliable, it's not useful.
Yeah, for me, I just try to not write bugs in JavaScript, and that seems like all right. So.
Yeah, I don't have any bugs, so, you know, that's why I don't use debugger. I don't ever have any bugs, so I'm not really sure. Like, it's cool. If you have
skill
bugs,
issue.
I mean, you could use one, I guess. I mean, I
I
don't
get
know.
it. Yeah. I get why Prime might need one. you
Yeah.
know.
Yeah, that's because I always
Right.
forget no mistakes. It's just like if I could just add that to the end of my AI prompt, everything would be great.
Yeah.
See, that's the problem. You got to put it in the agent instructions, so no mistakes is in every one. See, make it secure, make it good. Don't put it in a Firebase bucket with no authentication.
But also, if we could expound on why I don't think the Chrome debugger is very good. So going further along those lines. So again, in order for a debugger to actually be valuable, it has to do a lot more things than just stopping where I tell it to stop, which already it didn't do. So the other things it needs to be able to do is gather and like marshal and display information to me like cleanly and quickly, right? And it also doesn't do that very well. Like, yeah, it kind of has a watch window that's not absolutely horrible or anything, but it can't do any of the kind of stuff like I love like all the RAD debugger features where you can kind of go like, hey, here's my data structures. I want to turn that into tabular data. So like walk this linked list for me and show it to me like it was a table and like all that stuff. Like can't do any of that stuff as far as I know. And if you wanted to do that stuff, you'd basically be like programming JavaScript. You know, you'd have to be like writing your own like JavaScript stuff to do that right in there, which again is taking me more time. I just do a console log. And so I think like, yeah, like Chrome debugger is pretty mediocre. I'm glad they built it, but it's not in the top tier. Like it's not an S tier debugger by any sort.
Oh, we got to come back with a debugger tier list. Casey, we're going to do that offline, and we'll publish a video.
I think
So
that would
Ryan,
go hard.
actually, could we end with some of that? Can you talk a little bit about like the cool RAD debug features? Because like some of that stuff is really cool. Most people don't know you can view like 3D models in RAD debugger, right?
Yeah. So the 3D model, like some of it's early. So the 3D model, it's solid, but it's. I need to work on each visualizer is like a complicated problem that I have to dig into later. And so, but I do have a 3D visualizer. So basically, the way it works is basically the debugger's got a watch window, and in the watch window you can enter expressions, and they show you can expand them and all that kind of thing. You can also extend these expressions with like visualizer rules. So if you wanted to view the very common example is viewing like pixel data or bitmap data. If you wanted to say, for example, like I have this pointer to some giant blob of data that's just a sprite sheet or some font atlas or something like that. What you can basically say is like, okay, I want to say that this is a bitmap, and then I want to specify some extra information about like what kind of bitmap it is, like how big, how wide is it, how tall is it, what pixel format is it in. And the expression language, like in the debugger watch window, just allows you to express that kind of thing. So you can say like bitmap, and then the first argument it's like a call to bitmap. And you can say, here's my pointer, here's my width, here's my height. Those are just expressions, so they can come from variables in your program. And then you can say, here's my format. And then you can expand it, and it's going to show you an actual preview of the image itself. You can also like pull it out to your own tab and like see like, oh, like here's a fully featured at the limit. Like once I'm done with it, it'll be fully featured. but it's like you pull it out to a tab and then it's like, oh, here's a bitmap view. I can pan around, I can zoom in, check the pixel values and all that kind of thing. Now, every visualization feature in the debugger is sort of implemented in this way. So another common one that debuggers will often support is like a memory viewer, like a hex view of some memory. It's exactly the same feature in the RAD debugger where you can say, okay, memory, let me call memory, here's my pointer, here's my size. You can say like number of columns, all kinds of parameters that you want to do for building this hex viewer, basically. You expand it, it's just a memory view of whatever parameters you specified to it. As Casey said, there's also a geometry one. So if you have to specify some pieces of information where you can say like, here's an index buffer, here's a vertex buffer, here's how many indices I have, here's how many vertices I have. I don't know if you need to specify the number of vertices. I have to go look at it. But you can basically say this kind of information, and if you expand it, you just get the 3D representation of like, here's all the geometry data that you actually wanted. And because this is in a watch window, and it's not just like parsing a format that you dump out of your program, you see it update live as you step. So you actually like step over as these vertices are being built, and you can see the vertices change in real time. So it's way more useful than like dumping it and then dumping it to an OBJ and then looking at like some OBJ viewer, like this 3D model or whatever. Same thing with texture data. And so there's also a bunch of other visualization features, like more basic ones, like viewing multi-line text, for example. It's something that every debugger has to do anyways to show you source code, but it's like, you should just be able to apply that same exact path to like just viewing any arbitrary textual data. The disassembly viewer is also implemented this way. It's just a visualizer. And then there's a bunch of different rules that you can introduce to like change how the watch tree, so when you put in like a watch expression, if you expand it, you get rows generally either formed by looking at the members of whatever type you expand or something like that. There's a bunch of ways you can customize exactly how that looks like as well. And that's sort of more like sort of what Visual Studio did with NatVis. It's a very similar kind of, although it's not you don't specify that in XML in the RAD debugger, but you can do like the same kind of thing there. And then I guess the final layer, I could dig into more of any of that, but the final layer on top is you can also automatically associate certain types with certain visualizer expressions. So you can go ahead and say, I've got a struct, it's called bitmap, it's got a pointer, a width, and a height, and a format. And I'm going to say, if you evaluate this type anywhere in the program, or anywhere, like if you're in the debugger and you're evaluating anything of this type, just automatically say it's a bitmap visualizer. So you're sort of extending type information. You can put this directly in your program, you can put it in the debugger configuration, like really wherever you want. And then anytime you evaluate that in the debugger, by default, it'll show you that visualization automatically. So that includes hover evaluation. So if you hover the bitmap variable in your program, you'll see the bitmap just pop up. If you put it in the watch window, it'll just be the bitmap. Like it's, that's sort of the final layer to it, where you can basically extend your program's type info to be automatically associated with this visualization information. Now you can always go back. Like if you're like, I don't want to look at it as a bitmap, I want to look at it as a struct because that's what it is. You could always reverse it. There's a way you can do that inside of the visualization, like or within the expression syntax as well. So, but yeah, there's lots and lots of stuff you can do, and that's a good first run through, I think.
It also loads fast.
Yeah.
Yeah, I mean it's not hard to beat Visual Studio.
Yeah.
but
Visual Studio can't beat Visual Studio, so it's more difficult than maybe they think, you know? So just throwing it out there, I feel like it's a cool feature is that it actually loads.
Yeah.
Well, also, like some of the things that Ryan was talking about just then are important in the way that I was trying to describe before. In other words, it's really important to remember that a debugger having a feature doesn't matter if it takes you longer to use that feature than Printf debugging would have been to find it, right? Or we can extend, like, the phrase Printf debugging, we're using that as shorthand because, like, for bitmaps, you wouldn't be Printf debugging, but you would be doing a similar thing, which is, like, dumping the bitmap multiple times. I've literally written this code before I had RAD Debugger, where, like, in image processing code, I just insert like dump image here, dump image here, dump image here, dump image here, and I look to see, right, like where did the problem happen, and I'm like, oh, okay, right, and so it has to be faster than that, Because if it's not faster than that, there was no point to the debugger having this feature. And so some of the things that Ryan's talking about are way more important than they sound. The ability just to view something as an image in your debugger isn't enough. It's really crucial to have the ability to also say, look, when I built this program, and this is a really cool feature of RAD Debugger, when I built this program, I just included this little macro that I put that sticks some stuff in the type information automatically when I build the program that just says anytime I'm looking at my struct bitmap, structure, it should automatically set it up so that I can view it as the bitmap. That is like one little line of code I put in, and then for the rest of anyone ever using this program inside RAD Debugger, they'll always get it shown as a bitmap automatically with the right width and height and all that stuff, right? Mm-hmm. And that is a massive time savings for everyone. Whereas if it just has this way of like, I load a plugin and then I instantiate the plugin and I say that I want it bound to, like, if I'm doing that every time I have to view my bitmap, it's not saving me the time that I actually needed the debugger for. So all of these things are wicked important. And that's why it's so cool, like, that RAD Debugger is taking that approach of like, we actually care about saving you time, not just we cared about writing on the thing, it can view an image, right?
Features can view image. They got the thing on the front page.
That is not enough, right? It needs to be I can view and debug image processing faster than if I was printf. That is the actual feature you want in the debugger, because otherwise, why were you using it?
Yeah, you'll see demos of that exact feature too. I don't want to pick on anyone, but you can go look at like demo videos of they're like, look, we can view like images inside of our debugger, and in the demo video, it takes like 10 seconds to load, or like 30 seconds even to load. I can't even remember what it was, but it was just like, it's not just 30 seconds and then you can see it. It's 30 seconds every time you step. Like, it's not updating like right away. So it's just like, how is that helping me? Like, yeah. So, and also another good example of printf that's not printf exactly would be graphviz. Like if you log a bunch of like if you printf a bunch of graphviz like textual data, you get like a pointer graph view, or you can like print out a pointer graph and then you get this graph structure that you can visualize and see like, oh, is this tree wrong here, or is it here, or wherever. I haven't implemented this visualizer yet, so it's not in the RAD Debugger yet, but it's like that's the kind of thing where I'd like to push it, where it's like, no, you can just see your pointer graphs update in real time as you step, and so yeah, that kind of thing would be really nice.
Ryan, we have to write a real language though.
I know. I'm sitting here thinking the whole time, like, man, TJ made me do Elixir, and now I can't change. Like I can't change languages just to use the debugger.
We have Observer in Elixir. It is actually good. Like it actually
Wait,
is good.
Elixir is not a compiled language?
It compiles
to a VM stuff.
Yeah, and then it runs. But the observation tools are very cool because it actually is set up to observe everything across your distributed system, which is like sometimes kind of difficult. They can be running on other computers and everything, right? Like it's not so simple to do, but Elixir has very nice tooling around this.
Well, that's kind of a bummer, but like, yeah, any compiled language you could be using around, like, you could use Rust or something, right? It doesn't have to be C++, if it's compiled and produces debug info, then it can do it. So, you could be using it with, Ginger Bill was on, you could use it with Odin, I believe, just fine, right?
So Ginger Bill, well-known debugger hater, he said it doesn't work for Odin, so...
I doubt
he also
that.
hates package managers and LSPs as well.
But
no, that's just a joke from yesterday.
Okay.
Don't worry about it.
I happen to know it's false too, because he literally put in special features into the Odin compiler to work better with the RAD Debugger.
Yeah.
He was literally in chat 5 seconds ago saying, I'm going to go watch from the beginning so that I can see what's happening. I just wanted to say I use RAD Debugger every day.
Yeah, that's what I was going to say. Like,
I can't wait till he gets
Ginger
to this
Bill
part
knows
of the episode and he's going to be maulding.
I cannot wait for the comment. I actually do. Oh, okay, they were joking.
I'm about to get a very angry email and then he's going to watch the rest of the episode.
It was in his it was his Better Software BSC conf talk. He literally put, he was like, RAD Debugger. And he announced that it was coming to macOS, which it's not. So that was
macOS.
That was interesting, right? So I don't know. He basically is forcing. This is a well-known like Gabe Newell tactic. He will just announce something so that then everyone has to ship the thing because it's been said publicly, right? And so like he took a page from that playbook as like, well, if I announce it's coming to Mac, it's got to come to Mac. Like,
that's TDD, right? Talk-driven development.
Yes. Yes. Right. PDD, press-driven development. Yeah.
Well, I'm very happy, Ryan, you came on the stand-up today to announce announced Linux is going to be happening in the next few weeks, so thank you very much for doing that.
That's crazy. You heard it here first.
Yeah, you heard it here first.
Thank
And
you.
last.
And Ryan said Tim Sweeney personally told me that we would
Right, there you go. Yep.
Yeah. Well, thanks for having me though. It was a lot of fun.
Yeah, this is great. Thanks
learned
for
a lot of cool
explaining
stuff.
how complicated step stuff is.
It's so ridiculous when you think it's going to be easy, right? It's like, I'm just stepping over this line. It's like, nope.
Yep.
Yeah,
Sorry,
the
buddy.
recursive one really blew my mind because that
Yeah.
actually that one I was...
Because
I
now
have
you're
never
counting,
once
you're like
thought about
ref
it.
counting basically, right? Like,
Yeah.
Yeah.
I thought the stack
Yep.
pointer thing was really clever. Do you use the stack pointer effectively, like save the original address at that time, and then until you return to
So-
that stack pointer, you're like, I'm somewhere within the recursive realm.
We do have that path, but we actually figured out something cleverer for the recursive step case. Because generally, like,
Prime,
if
nice
you
try, buddy. Nice try, but actually you thought of something not stupid.
Okay, first off, owned. Second off, wrecked. All right, so tell my dumbness how you do it then, Ryan.
I remember when I was naive, I thought that might be an option.
Actually, you know what? I want TJ to explain it really quickly.
Yeah. Anytime a guest tries to politely say how they did something, Tej is just like, this is an opportunity to make fun of Prime.
Yeah, that's true. For me, stepping's very easy. I just do left foot,
Yeah.
right foot, left foot, right foot. That's like what I was showing earlier. I literally did a live demo. I
Yeah.
was
I
like,
didn't
here's
even
how
think
I
about that,
walk.
dude.
I'm stepping right now.
Okay, so what is the cleverer way?
Yeah.
Yes. So the clever way you can do is instead of checking the stack pointer on every recursive, like every recursion downstream of wherever you wanted to step over, you would hit that trap and have to check the stack pointer. What you can do, and so like recursive calls get very expensive to step over that way. What you can do instead is you can basically say when you call into the recursive call, or really whenever you call into anything, because it could call into one function which calls back into the same function. It could be one of those like ping pong recursions. So anytime you call into anything, I want to catch whenever that call returns back to me. Which I can't rely on the code address to do that, because again, it'll hit that trap first. So what I can do instead is basically turn off all the traps that I've set to catch this step, and then I'm just gonna completely fake an instruction pointer on the stack. So because when you call, it pushes the return address of the instruction pointer onto the stack, and then when the call completes, it'll jump back to that
Nice.
that call address. Yeah. So it's super nice, because then you can say after this call happens, it's gonna have pushed some address onto the stack, which is the real return address.
I'll rump it.
I'm gonna fake that.
Nice.
And then whenever they return, I'll get an exception, not from an int3, but from I just executed some whatever the bogus address was. We happen to use 911. So we just say so we put 911 in there as the return address, and then we'll get an exception that's like, oh, like I can't even access that page, like there's no code there. I'm trying to access address 911, and to the debugger that means, oh, you've finished the call, move back to the original return address, and then reset all the traps. So
Very clever.
Nice.
Question
Yeah.
that I have. Two questions I have, actually.
okay.
So the first one is...
All right, hold on. I gotta pee. I have
Oh
to pee.
my god. Okay.
Hey, Prime, nice shirt. Did you guys see his shirt? It's pretty good.
I didn't see
What was the shirt?
Just when he comes back, you'll laugh.
Okay.
Casey, just ask your questions. It's okay. Prime can watch it back later.
Well, can you go grab, like, when they edit this together, grab video of Prime still sitting there going like,
Oh, smart, very smart.
right?
I
So
thought
it
you were
looks
gonna
like
do the
he's
thing-
watching the whole time.
Well,
Right.
at the tower, because we used wireless mics, I think 1 or 2 times he went pee with the mic still on, and you could hear it in your ears. Trigger and assert when I click here,
That's sick.
which is pretty good. That's courtesy of low level.
Hey, can we move at least the line down?
Dude, oh my goodness. Prime.
Oh God, Prime, he's doing it. No.
That's literally
And it
like
was
the
like-
Naked Gun, right? Like, that's literally a scene from the first Naked Gun movie.
Yeah. And I had in-ear monitoring, for like our mics to make sure levels were fine and stuff. So like, I'm just sitting here. I'm sitting in the middle of the room, and I just hear him, and I'm
You're
like, "What is
Prime's peeing
happening?"
again.
Yeah.
Okay. So my first question is, what happens, because I have no idea, what happens in that scenario with, like, the return address, the special return address stack? Does it actually, is it smart enough, is the CPU smart enough to go, like, somebody modified the IP on the actual stack, so I'm gonna, like, go modify the return address stack? Or does the CPU always, I've never looked at this before, does the CPU always check when it pops? You might not know this because maybe it just works. When it actually goes to do a ret, does it just check the return address stack and go, if it didn't match, then I don't do it or something? Or do you know?
To my knowledge, it always will just take the address and jump to it. So it'll and I don't know for sure because it did just work.
Okay.
Where basically we're like, let's just phony this address, and then it just went to it, and we were like, okay, it went to it. So then
Ed says yes. 100% you're right, Ryan. Low level TV confirms in the chat.
Nice.
Confirms what?
Exactly what you said, that it doesn't check.
Ah, okay.
Doesn't check.
Did you say it doesn't? It just does a
check.
pop. I don't know. That's what
But
I
it
just
has
said.
to check. So just to be clear, inside a lot of CPUs now, there's the stack as you think of the stack, meaning the actual program stack that we push like arguments and stuff on, or like stack variables or whatever the crap, right? Like things that don't fit in registers when we're passing or any other things like that. And we push the IPs on there, but that's not where the IPs to return to actually come from. They come from a thing called the shadow stack, right? Which is like another thing that's kept as like a separate, right? You know what I'm saying? Anyone? And there's also this thing called There's also a thing called a return address, but there's a bunch of things in the CPU that are tracking this information. It's not actually from the stack anymore. Like that's kind of like old news, right?
Low-level TV is saying the shadow stack is rarely used. They go in the real stack.
But it's there. So what happens if that is? What I'm asking is, what happens if that is on?
We should just get Ed in here, and he should just explain it.
Okay.
Next episode.
Next episode. That's true. Yeah.
I want to know what happens
Friday?
if you. Because I don't know. Like, I assume the CPU actually has like some kind of a path for this or something. Meaning, like, it would look and go like, oh, someone did modify the stack, so I can't just assume that it's.
Yeah.
I don't know. Like, I don't know what they did there, and maybe I can probably just go read it. Like, it's probably in the Intel architecture manual, right? So I will go do that after. But I'm just curious if you ran into
spec. Well, it's probably in the W3C.
Yeah.
I did not run into that.
Okay, so it just
basically
works.
I did the naive thing. Yeah, I did the
works.
naive
Okay, cool.
thing that assumes it is on the stack, and then it worked.
Yeah.
So
I only know about the shadow DOM, so.
Shadow DOM. Well, because there's stuff like that where, like, if you do code pages, right? If you do self-modifying code, for example, that doesn't really work anymore unless you invalidate the instruction cache, right? Like, that was a thing that actually broke because of having, like, multiple buffers. So I didn't know if there would be something like that with all these additional ways that return addresses get checked because they just assume that no one's patching the return address. And so I didn't know if that was an actual assumption. And so you would be like, oh, yeah, we had to call the, like, invalidate the return address stack thing or whatever, right? And or if it just works. And I guess the answer is it just works. My second question was, would a data breakpoint work for that?
You got to expand on what a data breakpoint is.
If you set a breakpoint, where you said this at this location on the stack, I am setting a breakpoint if anyone reads it or something like this.
Yeah, I guess you could. I guess the reason why you wouldn't want to is to keep those slots open for user breakpoints. Yeah. So I didn't think of doing that, but I think you probably could do that. I don't know if it would catch will that catch instructions that aren't literal reads, but just mechanisms that the CPU uses to pull the return address? I'm not 100% sure, but it's a good idea.
Like with the ret maybe bypasses the data breakpoint, possibly, right?
Yeah, I'm not 100% sure.
I don't know.
All right. I know nothing, but I'd like to shoot my shot as well. Could you push a fake stack frame on that has a single instruction function that is just an int3 or whatever the break is, and then continue on and let it go, and then when it comes back, it has to bypass through that function no matter what?
In one sense, so we actually started this idea back when I was prototyping stepping. We started with that idea. We didn't move to 911.
Just like, yeah, we tried that. Dumb. Oh, nice try. how can I say this in the nicest way since I'm the guest? And I'd like
He
to come
literally
back on and
said
talk-
they started with it. Like, he's basically saying that Prime's idea was good and it was the same idea as them. And T just like, well, that means Prime's an idiot. All right, I guess he doesn't know
Dude, I'm
anything.
collecting L's right now.
Yeah, and like how did you get there from that? He said they started with it. Like, it was
Casey, you have
their
a great
idea
point.
too.
Casey, you have a great point. You're very smart.
Shut up, TJ. TJ just does not want these L's to flow down from
He,
you,
does, he
Casey.
can't handle you having to win Prime. He can't handle a W
All right, fine,
in the Prime corner.
I'm
can he?
literally wearing an I Love TJ t-shirt. Oh my god! Just to like help like bolster his confidence, and he's still dunking on me.
Yeah. True.
Yeah, so we did start with that. We did push an extra frame onto the stack, but we just, instead of moving to 911, we just allocated a code page where there was an int3, and then put in we changed the return address to that. But you can save that extra code page injection. Like, it kind of gives you the same effect, but when you move to address 911 instead, you don't have to inject that extra code page and treat int3s differently. Like, it kind of just gives you, it's just a little bit simpler version of the same idea. Now, I don't think you'd want to push further onto the stack, because then you're kind of changing, like, you know, how deep is their stack? Are they close to a stack overflow? Are you doing things that are like, you know, you're kind of changing the way the program is running a little bit too much, I think, in that case. I mean, you could do it, though. Well, yeah.
You would
It sounds like
probably
you could do
take
it.
that approach, Prime, if you actually had some things you needed to do. Like,
Right.
like if you
So
had
actually,
if you had a
yeah.
really good like a reason for injecting more code, that would probably
Yeah.
be the right thing to do, right?
Yeah, so you can actually
Smart
test
Prime.
this, too, and
Let's go.
this is actually how Visual Studio, like, if you're in Visual Studio and you want to evaluate a function, it'll actually do that. So so inside the watch window, if you say, like, I want to evaluate this function, or in the immediates window probably, you want to evaluate a function to evaluate it, but it's a function from the program, what it'll literally do is take your selected thread, and it'll push a new call frame onto it and call whatever function you wanted to run. And you can actually test and verify this. You can put, like, call sleep 1000 or whatever, and then if you pause the thread, it's in sleep on top of whatever code you were actually executing. So it doesn't inject a thread, it just uses whatever thread you had injected, or you had selected. So
You
that
may
actually
not-
does...
You may not
Go ahead,
realize
sorry.
this, but you just insulted me gravely by saying that I have the same level of ideas as Visual Studio, which is a little bit. That's
the meanest thing anyone said to him today.
It hurts. It hurts a little bit. Yeah, dude,
I'm so
you
sorry.
and Visual Studio, same ideas, man.
I-
Good job.
I want to be clear. I would never. I would never. Okay, there's a line between friendly banter and proper insulting, and I would never cross that line for my good friend Brian.
I'm so sorry. I did not... yeah,
Can-
I didn't mean to offend.
Can we get the Primogen subtitle changed to Visual Studio Developer at the
He never shows his,
Yeah.
even though I write good ones
Okay.
for him.
No, that's because I actually use my real camera as opposed because if I didn't, I'd actually get the leggy version of
Yeah,
me
of
seeing
him.
myself
Yeah.
talking. So I have to use
Yeah.
my real camera.
All right, so debuggers, everyone, they're awesome if they're good, and they're
How do they
useless if
work?
they're not. Right? That's the TLDR for this stream. Is like, if a debugger is awesome, you should use it because it saves you a lot of time, and if it's not, it's just a waste of time, and you can keep doing your printf debugging because it will be just as good. There you go.
Well, I actually do. There is something inside of me that always comes to the same like kind of conclusion, which is I've also not used enough like Vim dapping. I haven't dapped hard enough with the boys yet.
Is that
to
when they
actually
do
determine-
the thing like this?
Oh,
That
Bill
is-
Gates
that's
does
that.
this, which is my favorite version of dapping. But when that sometimes I think maybe my speed at a debugger is also skill issues. That maybe I need to actually invest more into learning the DAP side of things and the navigation being fast with it. But I also don't run into that issues very often. That it's like. So it's like it's been this kind of a difficult thing, but I need to give Pry. Pry, by the way, is the Elixir version of some level of debugging, so I'd like
Okay.
to pry it up and drop that at Printf Debugging after this because you guys make debuggers seem so like this like exotic place that I gotta go. But I also don't do game development or C++ or any of those things.
Why don't we do it when next time you're going to be doing a project in a compiled language? Like whenever that next happens, right? We should do a stream where we'll do some debugging. Like we'll show you what we normally do. So you can just see here's how we do it.
Let's do a good C. Let's do like I wouldn't do the devil's language C++. Let's do the Lord's language C.
Okay.
Or Odin.
Yeah.
Yeah.
Learn
Odin could be a
Odin
great one
and
because
debug.
Odin's like is actually trying to make stuff good for RAD debugging. So let's do that.
Yeah. Both of those will work.
Right. I will say though, the thing, if you're not in like compiled language land like this, when your language has a REPL, you can get some of the experience from like when you're running Elixir and you're running you can run stuff from the REPL, you can send messages, you can go inspect data, you can do other. So there is there are some other options too that you can explore even in some of these other languages.
Well, sure, and some VM languages have full debuggers, right? I mean,
True.
Java does, right?
Yep.
Even when it's
Elixir
running in a
does too,
VM, you
but
can do full debugging in Java, right?
Yeah, I think Python has PUBG or whatever it's called. That's also like
PUBG is the name of the debugger.
In my head, I call it PUBG, but I actually can't remember what it is. But it's like PUBG.
It's pronounced PUBG. It's a video game.
Yeah.
Okay.
It's completely unless you're playing something completely different than everyone else has been playing. Probably.
All I know
PUBG
is that
Underground, crazy.
Yeah.
all I know is when I saw it, I had such severe dyslexia that all I saw was PUBG, and so now I can't unsee it, and so I'm just like, it's PUBG. That's what the Python one is. That's all I know.
For some reason, I played PlayerUnknown's Battlegrounds for many hours and somehow never thought PUBG. And now I will.
Casey, I'm pretty sure if you were on the stand-up when you were playing it at that same time frame, it would be top of mind.
We should actually do, because I've never played PUBG, we should do like a Casey introduces us to PUBG. God! I mean, it has been so long since I've played it. I would be the worst. We'd just all get shot immediately. Would be what would happen. I'd be like, well, I didn't get a chance to show you anything, but sorry, guys. But we can try.
I like that.
Sure, I'd try.
Next stand-up, we'll just play video games.
We're just playing PUBG.
That's actually much closer to a Fang level startup, anyways.
Friday stand-up. Time for some team building. Let's pick a video game.
All right,
team
folks.
building stream would be so funny.
Okay, we'll talk about that offline. I gotta go.
Right.
I got another podcast.
Oh, sorry. Our bad. Podcast, TJ.
Sorry.
Hey,
did
Ryan,
have some good ideas. I want it to be clear.
Yeah.
He did have some good ones.
I appreciate that. Hey, Ryan, where can everybody find you at?
You can. I'm on Twitter or X.
I'm linking it right now.
It's Ryan J Fleury, Fleury. And then I've got a Substack that I have a couple of blog posts on like debuggers and how they work, and then I've got a bunch of other stuff. That's rfleury, FLEURY.com. And then I think that's basically everything.
Where can they find the RAD Debugger?
Oh yeah, you can go to github.com/ it's kind of a complicated URL, but it's github.com/ actually, can I put it in the chat?
Yeah. I literally.
You
have
can also
no
just
rules in
search
my
for
chat.
RAD space debugger or epic space RAD debugger. Usually in Google it will come up.
Yep.
Yeah, I guess I don't have. Studio chat. Here we go. I just see.
Yep. Someone already linked it. It's RAD Games extension RAD Debugger.
Your fans are in the chat.
Yeah, you got a lot of fans. Is the return address from your Substack 911?
No, but it maybe should be.
Yeah,
that's a good idea.
Brian, you did it.
I got one.
He did
It's a good idea.
I got one. Take that, universe. All right, everybody, thank you very much for joining us. Casey, computerenhance.com if you want to actually learn how computers work. TJ, he streams, by the way, and the name is the Primogen. Thank you for joining us.
Thank you very
TJ,
much.
that was a great outro. I nailed that.
was so good.
That was pretty damn good.
Thank you.
Boot up the day, vibe coding, errors on my screen, terminal coffee in hand.